Hey mathematicians, today we're going to learn how to model decimals. Our TEK for today is 4.2e to represent decimals including tenths and hundredths using concrete and visual models and money. Our learning goal is today I am representing decimals in multiple ways, so I can communicate large and small numbers efficiently. I'll know I have it when I can define a decimal as a number smaller than one whole. I can read decimal place values to the tenths and hundredths, and I can model a decimal using number lines, decimal disk, decimal grids, base 10 blocks, and money. Let's look at our real-world connection. Have you ever been shopping for something with your hard-earned money? How would you feel if you didn't get enough change back after paying? You need to know about decimals, which is how we represent money, to make sure you're getting the correct amount. We have a coin song that we like to use that I'm going to link in Schoology for you. I encourage you to go listen to it. It's really fun. Let's review our vocabulary really quickly. So a digit is any numeral from 0 to 9. Remember, when we combine these digits, then we create numbers. A place is the position of a digit in a number. For example, in 456, the 4 in the hundreds place, the 5 is in the tens place, and the 6 is in the ones place. A value is how much a digit is worth. For example, in 456, the 4 is in the hundreds place, the hundreds place is worth 100, and you have 4 of them. So in total, you have 4 hundreds, or 400. So the value of the 4 is 400. Whole numbers are similar to counting numbers. They have no fractions or decimals. So an example would be 0, 1, 2, 3, 4, 20, 50, 100, 200, 1,000, 1,000,000. Those are whole numbers because they have no parts or fractions or decimals. A decimal number is showing you a value that is smaller than one whole. It's represented as digits to the right of the decimal point. For example, 7.05. So 0.5 would be our decimal. All right, let's get to our mini lesson. So before we begin, let's review decimals. Remember, when we have digits to the right of the decimal point, we have a number that is smaller than a whole. We use place value to read these numbers. We read 946 and, remember that decimal point, we say and 94 hundredths. So the place value that our number ends in is the place value that we read. Just like we can model ones, tens, and hundreds with base 10 blocks, we can also model decimals, ones, tenths, and hundredths. Hear that TH at the end of those words? Tenths, hundredths. All right, so this traditionally, we're used to seeing it as a hundreds block. But for decimals, we're going to use it as one whole. So that is one whole something. Let's pretend it's a cookie. So if we took that cookie and we broke it into 10 parts, right? We took that one whole cookie and we broke it into 10 equal parts, we now have 1/10. So we could use the tens place value block to represent tenths if our hundreds place value block equals one whole. Now imagine if we took that cookie and we broke it into 100 pieces. This little crumb of a cookie that you're left with is 1/100th of a whole, one part of 100 pieces. We can also represent decimals using number lines. This number line is split into 10 equal parts, so it models tenths. There are 10 spaces between 0 and 1. Remember, we count spaces or jumps, not dashes. So if I start at this first dash, this is my 0. Then I have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, And when I get to 10 tenths, right, I have 10 whole pieces. So 10 pieces of a cookie make one whole cookie, right? If we took that cookie and we broke it into 10 pieces, if I have all 10 pieces, I ate one whole cookie. This number line is split into 100 equal parts. See all these tiny little dash marks? These model hundredths. There are 100 spaces between 0 and 1. Each bold line marks every tenth. If you'll notice, just like our number line in tenths, those lines, those tenths, line up with one another. So if we took 1/10 and we broke it into 10 more smaller pieces, we now have hundredths. So if we're jumping from here to here, that's 1/100th. If we jump from here to here, that's 200ths, right? So that means there are 100 pieces now that we broke that number line into. This is a decimal grid. If we represent one whole as an entire square decimal grid, then we can divide it into 10 equal parts to model tenths. So imagine just this big square. This is our whole. We took that whole and we broke it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So now our decimal grid is broken into tenths. If we represent one whole as an entire square, we can divide it into 100 equal parts to model hundredths. So what do you notice from our tenths grid to our hundredths now? I'm going to do that one more time. Tenths, hundredths. Yeah, so each tenth now has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 smaller pieces inside of it. So we took each tenth and we divided it into 10 more smaller parts, giving us a total of 100 parts of a whole. A decimal disc are similar to decimal grids. The whole circle represents one whole. So imagine you have one whole, looks like a pie, doesn't it? So we're going to pretend this is one whole pie. It is divided into 10 sections representing tenths. So you're having a birthday party, you really love pie, you have 10 friends over, so you cut the pie into 10 pieces. Well, guess what? Now, your entire school shows up to your birthday party. So now you have to share this pie with 100 people. So you have to take each one of those pieces of pie that you already cut, those 10 pieces of pie, and you have to cut those pieces of pie into 10 more pieces. This will give you hundredths. There are 10 hundredths in each tenth. That is important to know. 10 hundredths in each tenth. Money. Coins represent parts of a dollar or amounts smaller than one whole. We can represent decimal place value with coins. So $1 is equal to one whole, or 1 and 0 hundredths, 1.00. One dime is equal to 1/10, or 0.10, 0 and 10 hundredths, 0 and 1/10. Listen to that again. 0 and 10 hundredths, 0 and 1/10. Now I have a question for you. Are those the same value? 10 hundredths and 1/10. They are. So 1 penny equals 1 hundredth, or 0 and 1 hundredth, or 0.01. If you notice, I don't have anything in my tenths place, so I have no tenths and 1 hundredth. Don't forget the values of all the coins. We can add and subtract the amounts of coins as decimal numbers. So a penny is 1 cent, or 0 and 1 hundredth. A nickel is 5 cents, or 0 and 5 hundredths. Whoops. A dime is 10 cents, or 0 and 1/10, or 0 and 10 hundredths. They are the same value. A quarter, 25 cents, is 0 and 25 hundredths. and a half dollar, or 50 cents, is 0 and 5 tenths, or 0 and 50 hundredths. So equivalent tenths and hundredths. Shaded below is 8 tenths and 80 hundredths. What do you notice about these models? Go ahead and pause the video and look at these pictures and see what you notice. You should have noticed that they're equal. The only difference is that this model is broken into tenths and this model is broken into hundredths, but the amount that's shaded is the same. So that means that 8 tenths is equal to 80 hundredths. We can model tenths and hundredths as equivalent amounts. 10 pennies equals 1 dime. In the same way, 10 hundredths make 1 tenth. So if I have 8 dimes and you have 80 pennies, do we have the same amount of money? We do. We each have 80 cents. So I have 8 tenths and you have 80 hundredths, but we still have the same amount of money. If we both walk to 7-Eleven to get a slushie, we both would have the same amount of money. All right, let's do some checks for understanding before we get into our guided practice. So I want you to shade the models and fill in the place value chart to represent 23 hundredths. Go ahead and pause the video and see if you can figure out what 23 hundredths would look like. All right, so we should have a 2 in our tenths place and a 3 in our hundredths place. Because remember, we read the last place value. So if I read 23 hundredths, that means my last digit has to be in the hundredths place. And then we should have shaded 2 tenths, so 2 whole pieces of pie, and then 1, 2, 3 hundredths in our place value disk. In our decimal grid, we should have shaded 2 tenths, or 20 hundredths, and 3 hundredths. Devon went to the store to buy a new video game. He got this much change. How much money is represented here? Write it in the place value chart and write it in word form. Go ahead and pause the video. So you should have come up with 3 whole dollars. So that means we're going to have a 3 in the ones place, 25 cents and 25 cents. That gives me a total of 50 cents. Plus 1 dime would give me a total of 60 cents. And then 1, 2, 3, 4 for a total of 64 cents. So 64 cents is less than 1 whole dollar. So I'm going to write my 64 hundredths in my place value chart, meaning I have 6 tenths and 4 hundredths. In word form, remember word form, we use letters instead of numbers. We would write 3 and 64 hundredths. Model the number in the place value chart below and on the number line, decimal grid, and decimal discs. Go ahead and pause the video and focus on that now. All right, so our place value disc, we should have colored in 1, 2, 3, 4, 5, 6, 7 tenths because there's a total of 10 pieces, and we want to shade in 7 of those. In our decimal grid, it's the same thing. Our whole is broken into 10 parts. We have 7 in our tenths place, so we're going to color in 1, 2, 3, 4, 5, 6, 7 tenths. And lastly, for our number line, I'm not going to be able to get that to go away. We're going to count over 1, 2, 3, 4, 5, 6, 7 tenths on our number line. What decimal number is modeled by the base 10 pieces? Plot this on the number line. Remember that these are not tens, they are tenths, and these are hundredths. So how many tenths and how many hundredths do we have? Go ahead and pause the video now. Right, we should have 45 hundredths. We have 1, 2, 3, 4 tenths, and 1, 2, 3, 4, 5 hundredths. All right, I will see you for our guided practice.